have my own consulting firm and do a lot of freelance work. And in fact, right now, I'm doing a bunch of work with GraphQL and Relay and actually deploying it in a live system. So, of course, up until, what was it, the last meetup, I think it was, I didn't know much about GraphQL or Relay. So learned it quickly and already implemented it and really love it. So I have no idea exactly how long this is going to take. So we'll find out. I have a lot of slides. So if I talk too long and it goes too long, we'll just do the GraphQL part. And then we'll save the Relay for another time. This is sort of back end, front end. So that sort of splits it out, but they really both go together. So I was originally just going to talk about GraphQL when we talked a couple of meetups ago, but you'll be able to figure it out on its own, but you can understand how it works better in the whole React universe. If you aren't using React, then the second half won't mean much for you. But so, see if we can get this all to work right. So, who am I? These are just a couple of fun facts I thought was kind of interesting because I think I am significantly older than everyone in this room. So, I am just shy of 60 years old. So, I have been coding since 1974. So, to give you an idea of where that is. And I first taught myself BASIC on a computer that was probably half the size of this entire room. I had my first email address in 1976. Yes, emails did exist back then, believe it or not. Large computers actually swapped messages over modems across the country via a thing called UUNet. I worked for Bell Labs, which really started my career into C++. I was a C++ guru for many years. Co-founded an early startup here. There's tons of startups happening in Indianapolis right now. When we started, we were like the only startup in Indianapolis, and you'd probably be able to accumulate the entire technical resources of Indianapolis in this room at the time in the early 80s. But the claim to fame back then, which is kind of cool and new stuff is happening, is that we built one of the first full-color graphics cards for the PC and the Mac and started off the whole digital imaging revolution, which is fun. Then went to work for Adobe. After I sold my company, they were one of my clients. We sold them a lot of things, worked with them on things. So I worked with them. Worked for a decade there, converting Adobe Premiere, which was a large C code base, and writing a C code base of zillions of lines is fraught with tons of exceptions, crashes, and memory errors. So we recoded the entire application in C++. After doing that for a decade, I got really tired of C++. My brain was about to blow up. So I semi-retired and decided I was going to get into mobile and web. It was about 4 years ago. So my mobile and web career is only about 4 years old, but I am JavaScript I'd looked at years ago. You know, it was terrible, slow, everything else. Now it's so fast, it's awesome. I'm loving JavaScript. So I'm imagining the rest of you are too. So anyway, on with the talk. So brace yourselves. A few Star Wars memes are coming. And here's the first one. So let's talk about REST for a minute. What is REST an acronym for? Someone shout it out. Okay, you almost had it, but you both get one. Catch. Catch. Can I catch it way back there? Toss it on back. Exactly. Representational state transfer, which was originally defined by Roy Fielding in a thesis that he wrote in 2000. And for some reason, when I looked this up, I thought it was longer ago, but I guess 2000 really wasn't. I guess that is long ago in web time. So it's the de facto standard. It's what everyone uses right now for talking to servers. I'm sure everyone in this room pretty much, if you've done any front-end stuff and or back-end stuff, you have used some REST. If you haven't, then you're probably just learning JavaScript with no web development. It defines some simple operations: get, put, post, and delete. And one of the things that are important that we'll get to a little bit later is that a get operation in theory, same theory because things don't always work this way in practice, people, basically says it's going to get some information from the server And this has no side effects when I do a get. You can write things that will actually have side effects. But the whole idea is that if I do a get, this is something I can cache, I can grab onto, and I can pull back in, and I won't be causing any side effects mutating data. Commands like put and delete are basically about changing data up on your server. So these two things are basically what REST allows you to do. Of course, you all know this. Allows you to get things from the server, allows you to send data to the server. So what's the problem with REST? I can use my pointer here. Does that work? No, that doesn't work. I didn't set it up. So many endpoints, proliferation of ad hoc endpoints. And I think the room here was probably 3/4 front end, quarter back end. But I've worked on both sides of that. When I'm on the back end, you end up talking to a front end person, and you're working on this system, and they're like, yes, I need to know the number of poodles per pet store per state, and then a few hours later they call up, but I need one that's the number of poodles less than 20 pounds that is owned by some such person and cared for by this doctor. And before you know it, you as a back-end developer just start providing all these arbitrary APIs for your front-end developer. And it can get tedious, it's error-prone, and today I just looked at the Facebook Graph API, which has nothing to do with GraphQL, for fetching the social graphs, and it's hundreds and hundreds of API endpoints. So that's one issue with REST. Another issue, a big one in response to the Star Wars thing at the beginning, one that motivated Facebook to do this, is basically round trips between the client and the server. So not so worrisome here, where I'm sure Salesforce has a gigabit feed, but on a mobile phone, basically the issue is every time you basically make a REST endpoint to fetch some data, you're probably going to then turn around, fetch some more data. The turnaround time on mobile is a pretty large and significant value. And if you really want a responsive app, you want to try to get around that as much as possible. Your response structure may change over time. So obviously, I'm sending down this information, but I may want to add some more data to it, delete some data. How does my client constantly adapt to this? Another issue, again, for mobile, or basically when you're trying to optimize things, is data overfetching. Give me the number of pets in the pet store, and I get back the pet, their name, number of pounds they weigh, their sales price, and everything else, and all I really wanted was what kind of pets you had. So you can do that, make up a different REST API endpoint, but basically you've got to keep doing that. And usually no metadata. Basically, when I request something, I query the server, I just get a big blob of data back. Implicitly, the front-end developer, knows what that data is, and that's all good. But if they don't, then it's basically an arbitrary chunk of information. So fixes for REST. You could define your own ad hoc query language, and that's essentially what Facebook has done. They have created a query language, and we'll go into that in a bit. There are other things, JSON, patch diff, et cetera, if you're familiar with any of those other things, where you can actually try to minimize data transfer and update your state on both sides to minimize that. As far as metadata, REST introspection, anyone here use Swagger? Okay, a few people, good. It's cool. I've used it before, and up until GraphQL, I would have highly recommended it, because it's the way that I typically, and if you are doing a REST protocol and you've got a front end and a back end and you aren't using GraphQL, definitely look at Swagger. It's a lot easier if you're the back end developer to show your API and make it testable for your front end developers. So let's see here. Okay, JavaScript fatigue. Who's read this on Twitter, the whole JavaScript fatigue thing? Everyone? Sue, maybe? 2, 3. You guys aren't reading Twitter enough. My goodness. What the heck? It's on Medium now. It's on Medium now. Okay. Well, I read Medium too. Who reads Medium here? Okay, that's pretty good. Okay. Okay, so that awesome moment when everything else stopped, because not a new Star Wars trailer. This meme was actually before the new movie came out, but because a new JavaScript framework was released. And I'm the kind of person who likes to live on the bleeding edge, so I tend to love these new frameworks. I think that's what actually makes this area so exciting for me, is there's new things coming out all the time. So I know a lot of people think that's a big headache, but I think it keeps it pretty exciting. It also means you have to learn new things every day, like GraphQL, like you're learning today. So let's go over here. What is GraphQL? Okay, so queries describe, or queries that are issued to the server describe the shape of the data, what kind of data that the client needs, and the response is going to be back the shape of the data that the request was. I'll go into this in detail in a minute. The server basically interprets the GraphQL call and queries the database or any other source of data, and we'll talk about that in a minute. A new thing about GraphQL is it doesn't restrict you on the next step there. It's basically language, database, and protocol agnostic. So the implementation I'm going to be talking about is JavaScript, but you could potentially do this, and there are implementations in Python and other languages. The product that I am deploying right now uses RethinkDB. But that's, there's no particular reason on that. A lot of the examples use Mongo that are up on the web. You can basically use any kind of database. And in fact, as I'll show a little bit later, the graph that you're actually asking the server for, the information is actually not only database agnostic, but information agnostic, so that in your queries, you can actually combine multiple things and say, I wanted to access a database, but then I also wanted to go out and get some information from GitHub or, I don't know, Twitter or something else, and combine all that together. You can actually talk to lots of multiple endpoints that are past the server side for this. So we'll talk a little bit about that. And it's protocol agnostic. I'm actually using WebSockets in the product I'm working on right now. So there is actually no REST in there. Well, there's REST because of the web pages and things, but not for actually any of the communication other than fetching static pages. So, let's see here. Okay, GraphQL was invented at Facebook in 2012, but it was first shown at basically the React.js conference, and they open sourced a sample implementation. Let's see here. So what's the motivation for GraphQL? So a single endpoint. So I'll show this in a bit. If you basically want to use, well, I should say, while GraphQL is a replacement for REST, you still have to have some communication to the server. Right now I'm using WebSockets, but the default implementation for most of these things is to use REST that's just using one single endpoint. And when I actually set up my backend, a lot of other people will do something like /API or /GraphQL. That will be your endpoint, but that's the only one that you have in your entire system. It's hierarchical nature. We'll see in a bit. When you look at it, you're basically looking at a hierarchy of data, structured data that you're getting back. It's strongly typed. I know that JavaScript people don't always like typing, but so you're going to have to get past that a little bit. The typing allows you to do validation, introspection, and a lot of other cool things that you really basically have to have. And if you're developing on the server side anyway, you're probably already doing some sort of JSON validation or something. So you've got some sort of schema or type information already over there somewhere that you've done. So this kind of swaps for that. Introspection, like I said, when I actually go through some code, we'll see GraphQL actually allows the client to go and say, what data do you have? What kind of data? How can I query it? What are the types of the data? Which leads to some interesting possibilities. And it's one of the things that Relay uses basically for the front-end side. Okay, so this is, I talked about a minute ago, application layer protocol independence. Basically, you can use whatever you want to try to communicate back and forth. Essentially, when GraphQL is sending a query, it's just sending a query. It's just a big long string that's a query. The server side is basically parsing it down, executing it, and returning the results. So let's see here. What's next? So just a little bit of things. Graphs. So if you're a computer science person, then you know graphs. If you're not a computer science person, you may not know about graphs other than Facebook, social media graphs. So this is a real simple graph. This is called a DAG, a directed acyclic graph, because it's directed, everything goes down, and there are no cycles. Nothing points back up. These are typically used a lot in ASTs, abstract syntax trees, which are representations for programs or queries, which we'll get to in a minute. And in fact, the queries that are sent across on the other side are basically passed around through your server code as abstract syntax trees. I'll talk about why that's important. So that's a more restricted graph, but then we can have a full graph. So a full graph has nodes and edges, and they can be directed. They could be undirected. This one isn't. They can also be cyclic. So this guy comes down here, he goes over here, comes back up here. So we have a cycle. You will have recognized cycles if you ever tried to do JSON stringify on a object that points to an object that points back to itself, and you get an error that says can't do recursive objects. So that's what this is basically. So each of these here, we're going to look at them. If I give you an example and show how this does. So we've got a person up here that has some data with the person, that node. That person has a number of connections. In this case, these are Starship connections. Over here, these three. This one is a homeworld connection. So this person has some relationship to these three starships. They have a relationship to this homeworld. That's essentially where they're from. This starship, who has a pilot connection, which is the pilot for the starship, points to some pilot data, but of course the pilot came from a homeworld as well. So basically that's a graph, and people seen graphs before, understand how graphs work? Yeah, okay, thumbs up. That's a resounding yes. Lines and circles. Lines and circles. Yes, okay, exactly. You got okay. So now's where the interactive part comes. If you've got laptops, you can probably do this on the phone too. I haven't actually tried it, so it's going to be kind of small. So if you have it, and hi, come on in. So if you have a chance, I highly recommend you follow along. It's kind of fun. So I'll wait a few seconds for everyone to go to this. What this is basically is there is already on the web a thing called Swappy, which is the Star Wars API, which some people did, which is basically a server that implements a REST protocol to allow you to query all kinds of things about the movies, the characters, the starships, etc. What Facebook has done is they have taken and created a GraphQL front end to the Swappy system, and it's actually technically running on Parse. Parse, who knows what Parse is? Okay, a few people. Parse basically went away, and that was a database as a service cloud thing that Facebook had. They decided that that wasn't an area they really wanted to be in, so they got out of it, but they made it open source. And it's basically uses MongoDB as a backend. Yes? Oh, it is. Big. Yeah, Dream. I'll write it down. Dreaming big. Yeah, that's right.
Dreaming.
Dreaming big. All lowercase.
No, all uppercase.
All lowercase. And if you have any questions while I'm talking, just stop me and what? No, no, that's fine. No, do interrupt. If you have questions along the way, do interrupt. That's better. You can't. I can never remember things till the end of a talk. So please just.
Yes. There you go.
Does everyone have that or that wants to? Yep, yep. Good, good, good. Okay. Yes, seeing it. Move on. Okay, so I'm actually going to flip over. I'm just going to show this one slide. I've got slides for each of these, but I'm going to flip over to that actual site, and we're going to walk through all of this. But this is what we're going to see first, is a basic query. So give me a second here to switch things over to the right thing here. Okay, that's not the right thing. I'm going to put my glasses on so I can actually see what I've got up there. Oh, I'm on the wrong screen. Problem with multiple screens. This one. There we go. Okay. Basic query. And come over here. Okay, so one of the really awesome things that GraphQL supports is introspection, like I said. So we're going to do this a little bit different. We're going to do this interactive part. Then I'm actually going to walk through how you actually create the schema and do the back end and everything. I think the interactive will give you a better idea as to what is what's actually happening. And then I've got to move my slides over here. Hang on a second. Okay. Oh, oops. That's the wrong thing there. So, nope, I didn't. Hang on. Okay, so this right now, I've actually got. You can actually download this thing that's running up on Parse. I've actually got it running under Node on my laptop because I was worried that maybe Wi-Fi or something wouldn't work. So it's extra paranoia. But anyway, you're seeing. You should be seeing exactly what I see. But what's slick is that when we actually run the GraphQL server side, we can basically go over to, and if you followed the notes to that site, you'll basically see this. And what you're actually looking at is you're on an endpoint on the server that is basically working through introspection that the server has. So basically, we can make queries on the server and actually run them. So for instance, this on the side over here, this is where you put your query in. And I'm going to explain that in a minute. You can prettify it, which just cleans it up and everything. And then if I execute it, then you'll see what's happening. So to explain what's going on, normally when you actually work on queries, you usually end up typing type a query in here, but if I actually prettify it, it gets rid of it. In the this is called GraphQL, GraphQL. So this is basically a visual front end for the graphical back end, and basically allows you to go in and experiment with the database and the GraphQL schema that you have. So basically, whenever we put any of the queries over here and then run them, we're going to see the output over here. So the base part of GraphQL is that there are queries, as I mentioned, that we can make to the server side. We've got this schema over on the server side, I'll detail in a minute. And we can basically ask for data or information. So basically what this is doing is it's saying we want the person, and actually this query has a parameter, person ID, it's number 4, and then we want the name back from that person. In this case, that happens to be Darth Vader, everyone's favorite anti-hero. Now, if I wanted to, I could go in here and just add, for the heck of it, oops, I could add in ID. Well, you notice what happens when I start typing. I actually get code hints, IntelliSense, whatever you want to call it, that basically is looking through the schema that's on the server and then telling me what I can potentially type and query on. So if I go over here, click that, and then I come back up and run it, you'll see now we have the ID for that object. That's different than the person ID. That's the actual ID of the object within our entire graph. Now, how might I have known that if I didn't know that part? I basically could have come over here and clicked on docs. So basically, it generates on the fly from your schema in the back end documentation that you can actually walk through, which is really nice. So on any graph that we have, basically there's a root of the graph or the top of the graph that we saw up there, and we can make queries on that graph. So if I click on the root, it'll show these are all the different fields that are on the root of the graph that I can make queries on. So I can find all films, a particular film, all people, all planets, species, starships, etc. This is pretty slick, and you can actually nest in on all these. So I can go to all films. All films has these arguments. These are the types of the arguments. All films also has a films connection, which basically I'll go into a minute. Connections, if you remember the graph, the picture I had a few slides ago with the graph, those are the lines. Those are the edges. Basically, they're coming down the connections to other things. So on this connection, I actually have a page info. I have edges. I have a total count, the number of things that are in it, and then I have films. So basically what you're beginning to see is that you can go through all this and you can keep nesting further and further through the big graph of data that you have. And on any of these things, you can basically go and find out what the data type is, what possible things I can query on, and you can put descriptions. And in fact, they put in here. Let me see if they put it in here. Okay, so some of these descriptions are pretty lame. Let's see, reproducers. Okay, so not only when you describe your schema do you describe the data types and some other attributes, you can also give each of them a description. So kind of like Swagger, if anyone's used it, it's much nicer for someone working on the back end. They can walk through this, and if you put a nice English description in there, they can figure out what they should be querying on. So let's go a little bit more complicated. So that's a basic query. Let's put this over here a bit. And I'm going to close the documents here real quick. Fire that up again. Okay, so that was the one we did. Now we're going to go and nested fields. So this right here, basically what we're looking at is we're same thing again. We're going to ask the person ID, good old Darth, the name, their gender, and their home world. I run this. What you'll see as we get back, name Darth Vader, gender male, home world, Tatooine. So what's happened here is that we are having nested queries, and if you'll notice, basically the data is returned in exactly the same shape as what we were requesting it. So, I mean, it looks like it basically is JSON over there, but it maps to exactly what we have over here. And it only sends back to us exactly what we requested. We requested just these fields and got them back. I could have on Homeworld, I could go back over here if I wanted to and go, let's see here. There was a person, and it's a type of person, and there's a homeworld. Homeworld has a planet, and that's the information I'm getting back there. The planet has a name. So here's the first question. Anyone tell me who the person is with person ID number 10? This is you. You can't guess. You got to run. This is your chance to run it. What? You are right. Awesome. Oh, way too far. Yeah, the force is too strong. Obi-Wan, someone's paying attention. Awesome. Great. Very good. Yes. So, in fact, if we go back up here and we go back over here and type in 10, and basically we'll see it. Oops, here we go here. You see Obi-Wan, and Homeworld is Stujin, or however you pronounce it. So more of a Star Trek person than a What?
Same effort.
Oh, is that, okay. Yes. Is it?
Yeah.
Oh, I didn't know that. John Stewart. That makes sense. Okay, good. Okay, so basically those are nested queries. That is basically, we're not actually doing connections or anything deeper here. This is basically querying nested data that's on the person object. So if you can imagine any just plain old JavaScript object, you can have all kinds of nesting in there. These are just ways of fetching parts of the nested data in an object. Okay, so in fact, we go over here, you'll see basically, now this is a more complicated one here. So now we're gonna go, we're back to Darth. We're asking the same information that we did at the top, but we're gonna do a Starship connection, okay? Now, this is going back to the slide I had before. Basically, a Starship connection was one of those, over there you saw there were like 3 Starship connections. So this is basically saying I want to query the connection, the Starship connections that are on Darth, and I want to get the edges. So all of those lines give me each of the edges that are coming from Darth down to Starships, and then inside I want the node, the information, and in that I want to get the ID and the manufacturers. So if you look over on the right-hand side, basically what happens is we've only got one right here, one Starship connection. But if you had multiple Starships, which I guess he must have been Starship poor, then he would have had more down here under edges. This basically, the edges basically returns an array of all the edges. So we had the 3 edges over there in the previous picture to the different Starships. We would have, if that was this case, we would have had 3 items in the array down there, and each of them would say node. Basically, let's see if I have time to go into exactly why they're called edges and node and everything. I mean, beyond the basics. But so this is how you start getting connection information to data that is in your database that things are connected to. You know, this guy has many. This is a one-to-one. If you've done database stuff, you know all the different potential connections that you can have. Everyone with me so far? Any questions? I'll take that as a resounding no. Okay, so let's go and look at all connections. Okay, so what we're going to do here is, if you looked back over here, we looked at the root query, and this is our root right up here. So every query has a root, the top thing at the top of your query, and you've got to start there. These are the things that we can start with. So earlier we were doing person ID here, and now we are basically going to do all Starships. So just to give you an idea, all of these things that are over here on the right-hand side, all of these are just defined by your schema. This is nothing that's built into GraphQL itself, even Node, which I'll go into a bit. These are words, names, keywords that are defined by your schema. So if we come over here, we look over there, we can see that we have all Starships, and all Starships takes an after, a first, before, and last. These things right here, we actually aren't going to provide, allow you to do pagination. So, you know, if you're on Facebook, you typically, you know, don't want to do all users, because then you'll get back a very long chunk of data. So how do you do that? Well, you want to paginate. So you want to get chunks back. I want 10 at a time. I want the next 10. I want the 10 after where I am now. So basically, nodes and edges allow you to have these arguments that also allow you to do pagination. It's important. So if we go over, we aren't passing any arguments, so it basically is going to give us all the Starships. And close this out here again. So, and here's what we're seeing right now. So what we're seeing is we just requested the ID. And so this is all the Starships that are in the system. These are all the edges that point to Starships. We're asking for the node, the circle, and the information inside that node. We want the ID. Now I'm going to digress for just 1 minute, and I actually have a thing later that talks about this a bit. Let's see how I'm doing on time. Okay. These IDs, they look like gibberish, and they sort of are. Not exactly. Anytime you are working in GraphQL, and in particular, this is most important when we're doing relay, which I'll get to in a minute, but I'm going to talk a little bit about here. You actually have to have what they call a globally unique ID that you actually have to return in GraphQL. This ID is actually unique for each node in your graph that's over on the server. They have to be unique. It's the way GraphQL uses to identify things on the client side for like caching, for re-requesting things, refetching items. So basically, depending upon your database backend, they actually have some functions to help you generate these nice little global IDs that are unique amongst all nodes in your graph representation. These IDs are not necessarily the ID in your database or anything else. It's just a way of representing uniquely each of the nodes so that later it can refetch, cache, etc. Make sense? Maybe? Yes?
So, not about the ID, but going back to the all-star ship example. So, the documentation it says that after, first, before, and last. Is there any way to specify required and optional parameters?
Yes, yes. You can. Well, you can't. You can't specify. You can specify default parameters basically. So I can give it defaults, and then I can test if a parameter is given or not. And the parameters are always. Let me go back to the. There are no parameters on this one, so that basically looks like an empty call with no parameters. So if you do that, basically, those will either have default values or be undefined, but you can query for that. And then if you look back, let's see, you're back over here again. You notice all parameters to any of the GraphQL queries are named, and so they are not position based. So you can that allows you to have optional parameters that way. So you can put them in any order you want. The names just have to be correct in the data type, but you can provide a default for person ID. If I thought everyone always wanted Darth Vader, I could have made it 4. And then if I didn't provide anything, then if I just called person without any arguments, I would have gotten Darth Vader each time. Yes?
What if you wanted to like recursively go through and get like a whole tree?
Yeah. Yeah. Well, if you look at this one right here, so we basically are getting part of the top of the tree. We could then put things inside that node that require things inside that require things inside that, and so on. If you wanted to say, give me the entire Facebook social graph, there's not an easy way to do that. There's an easy way to get some pieces of it, which I'll show in 3 more, something like that. But you can basically, since you are defining these items up here, so any query, any node essentially has fields. That's these names that are over here. You could define, if you wanted to say, give me the entire graph, you can define give me the entire graph as a root query, and then it will send you back the entire database if you want. Yes?
On a related note, the first thing that comes to mind is it possible to do like a type of build, like a count or a max or a min or...
Okay, so yeah, so that's basically the beauty of it is that you can actually these over here, the connections that they have, which I'll show when we get further into it. The connections are basically an interface. So we'll get to defining the schema, but each of the items in the schema basically are an object. Facebook has defined a node interface, and that's what each of these are. They are a implementation of the interface, node interface, and which has after, first, before, and a few other attributes. You can create your own, basically all of this is totally definable. So for instance, I've got, the thing I'm working on is a event ticketing system. And so I needed to go and check for tickets that were on the event date that had been purchased, and I needed to filter by some things. So there's no filtering per se built into this, but basically you can add whatever arguments you want and then implement your filtering on the back end. So like I said, all of these, and that was the thing that tripped me up when I started reading GraphQL. I thought these things were all like, these were like fixed keywords after first. They have several of other those, and if you go on Stack Overflow, you'll find people get totally tripped up by that. It's all arbitrary. This is all programmed by the schema that you generate, which I'll show you in a bit. So there's a lot of flexibility. And to answer the question.
So basically, if you want it, then
You have to implement it.
Right.
Well, the beauty is you can start to do things if you've got your own system where you create an interface for, you know, standard typical filtering things, subclass from that, and so on. I think we'll see more of that going on. The beauty of GraphQL is it's usable right now, and Relay is very usable. I'm using it in production. It works great. But like all JavaScript frameworks, there's a new version coming out every, you know, month or something. So, I mean, they just released a week ago a new version of Relay, and I haven't upgraded yet. And there's like a change list is, you know, of new things is like 3 pages long. So you have to kind of just sit back and not change it every time something new comes out for a bit. Is there another question, or is that good? Yes.
So what happens if you describe like a cyclical relationship in the query? Like, does it explode in some spectacular fashion?
The thing is, if I come down here and I take out this guy here, let's see if we get the right, oh, one more. So if I come over here, you'll see it's giving me a red line. So I said I want all starships, but I haven't really said what is in the starships. So at any point somewhere down in your query, you are basically going to end up resolving at the bottom to some information. I can't actually go and resolve just to the point of a connection. I got another, that doesn't any good either, because so anyway, if I hover over this guy, where did my cursor go? I hover over this guy here. Actually, it should hover. If I actually run it, you'll see what happens. So it's another nice thing about GraphQL is when you start working with it, it basically says we expected a name. This is the line. What happened? Since we actually have to, so basically in each of these queries we have to have a leaf node. At the bottom we have to have leaf data. So we can't generate a query that recurses infinitely. Now, what you could do, and you know, people say, how do you prevent this? So if someone got into your GraphQL backend, potentially they could create a large query that, you know, was this, and then I want that, and the starships, and the people in the starships, and the starships of the people, and the people of the starships, and the starships of the people, and people of the starships, and then when that actually hit your database, you'd go, and you'd work for quite a while. So you have to start doing some potential, just like every new technology, there's some way that some hacker is going to potentially get in there and do some nefarious things. But that would require that the query is actually deeply nested versus doing something that has it automatically recurse infinitely. Make sense?
Sure.
Okay. Other questions? Yes.
Can you grab the connection in the opposite direction? Like you want to.
You can go forward and backward bidirectional. Yeah.
You want to get all people from the home world.
Oh, sorry, connections. I thought you were talking about pagination.
Yeah.
If I wanted to go the other direction, I can, if I wanted, well, if I wanted to get all the people, so from a home world, then I can go over here and I can go all planets. And then in there, I could go and basically say for each of the planets, I want to go in there and I want to get planet and I want to get.
There's also a good thing if you implement it, then you can do it.
What?
This is also a thing if you implement this.
Yes, yeah. If you implement, you can do it. Right? Yeah, yeah, yeah. I mean, it falls out here. If you create the correct nodes, then it does sort of fall out. It's not quite as much as like the filtering. Good enough answer? Not yes?
Yeah.
Okay. I'm sure. Questions for us?
So are the roots then basically, like in a Mongo context, kind of self-contained collections? So you define if you wanted to, you have to define a collection in order to use it in say in Mongo, or can you get at nodes that are deep in the chain directly without having to block it from some sort of global root?
Well, two answers there. So yeah, you have to define everything you want to access. But for instance, over here, back up at the top, in the root, these fields here, I basically, any of these fields that are on here, I'll show them. Maybe I'm doing this in the wrong order, but basically they are just calls to the other side, and it's given these parameters. So you can make up whatever you want on the other side. That this call could say all planets, and it could say fetch the weather, and on the back end when it's resolving it, and that's what's called resolution, resolving it. When it's resolving it, it could go out and fetch the weather from weather.com.
So the structure of your ultimate backend doesn't really
Doesn't define it at all. Exactly. What this creates is a graph mapping all the stuff that you have behind it. There can be a very close representation. There can be no representation at all. It's just, this is a way, at least on the client side, it thinks you've got this really slick, super cool graph database out there. You don't. You may have Mongo, you may have a whole bunch of JavaScript arrays that you're just passing information back in. Yeah, yeah. If you have, Mongo, if you're doing Mongo, then if you've got the schemas in Mongo, they tend to map. You can pretty quickly write schemas in GraphQL that map over to the similar types and schemas that are in Mongo. In fact, there's what's it called? There's one GitHub project that basically takes your Mongo schemas and spits out a GraphQL schema. Now, I wouldn't recommend that because you may not want to expose everything in your database. That's probably dangerous. So exactly. It's a very good, quick way to start. There isn't anything like that for Rethink. Rethink is another NoSQL, but it's kind of table oriented. It's a little bit different than Mongo. So you have schemas, but not in the same way as the nice Mongo schemas. So yeah, there are a lot of tools, and because of all this ability to do the introspection, there are a lot of people building all sorts of cool tools. As you can imagine, if your client can go out and fetch all this information, there are potentially all sorts of things that could be done with all this metadata. More questions? Oh, yes.
Yeah, so this might be too much in terms of relational database. What if I just wanted to do a swipe star against all star ships, and I wanted to see all of the values? Do I need to go through and go edges node and then type in every single?
No, you can actually put shortcuts in, and I could create an all starships, and then right now the all starships is returning the node and edge, this connection concept, but there's also, which we'll show later, assuming I don't run out of time, you could also return a GraphQL list, which basically has no node edges. It basically says, I'm going to give you this array back of things. Big JSON array of things, yeah. Now, you won't have any pagination. Part of the reason for the node edges is that it allows the graph to store positional information as you're walking through the parts so that you can paginate forward and backward. If you don't need pagination, it's a lot simpler. Just do the list. It's a lot less mental overhead, trust me. That was getting the node and edges down was a little conceptual trip for a day or two for me. So and it is for a lot of other people too, unfortunately. Graph theory is kind of crazy. So but yeah, basically the nice part about it is that you are implementing these things. It's getting arguments, and you're telling how to get the data back. Now, You don't have to think of it in terms of RDB. You can make, get this crazy data for me, and then you can have whatever arbitrary SQL query you want on the back end. But it is, because of all this is basically hierarchical based, it is, from the client side, it looks like a graph. So, I mean, if all you return is lists and no connections, then you really just have a big directed acyclic graph. You don't have the full connected graph. You've got the thing that just has a bunch of leaves. It's not going to be too exciting for your users, probably, but it works really well when you're trying to learn this. Play with the lists before you play with any of the node edge stuff, because you'll go, what the hell? So, and we'll get to that. So, oh, you're welcome. Other questions before going? Okay. So, let's see, where was I? We were on, we did all connections. I already did that one. Oops. So the next one was arguments. This over here, which we already kind of talked about. So basically here what we're doing, and this maybe shows a little bit more. So we're using the first here, the thing that we were talking about, pagination. We want the first 7. So if we go over here, we'll see there's 7 of these people over here, 7 of these things. But we're going to ask for the edges and the nodes. So we're basically looking down for these starships that are down here. I want the ID, the name, the model, the costing credits of each of these starships. But now, for each of these starships, they have a pilot and a pilot connection. Who's piloting the starship? So I can put a deeper query in there that says, on each of these nodes, get the pilot connection, get the edges, because there could potentially be more than one pilot, and the node, and then ask for the name and the home world. And then inside the home world, what's the name of the home world? So this is name of the pilot, name of the home world. So that's gives you an idea. You can start creating these pretty complex queries that sometimes it'd be very hard to do over in Mongo or SQL. And the beauty of it is, the thing that I like the best, and typically the way I'm using this right now and working, is that when I am developing and I want to create, get to relay, if we get to relay, which probably won't, if I'm developing some relay components and I want something to display, the tickets, the current tickets that are available for this venue and the price per person, blah, blah, blah. I basically come over here and I run this. This is turned off in production, but in development, I leave this on in our server, and I can go over and I can create these queries and try them out and basically run them and debug them until I am getting back the shape of the data that I want. So it allows you to not have to mess with a lot of code on the back end. You can just keep playing with this until you get basically what you're looking for. And this is so helpful. I mean, it's amazing. You get a little bit, anyone who's ever used Swagger probably knows the benefits of that, where you can, because in Swagger you can interactively play with the API endpoints, but you can't do crazy complicated queries like this in Swagger. Okay, so that was arguments. And all of these things down here could potentially have arguments, because these are fields, and a field is either a data or something that will get resolved to data that we'll talk about. And since it can potentially get resolved to some data coming back, it can have arguments on it as well. So, see where I'm at here. Okay. Forgot to do another candy bar. Let's see, I should go back here. I'm gonna pop back for 1 second and see if anyone's awake. So, anyone want to tell me what the population of Darth Vader's homeworld is? Anybody? Anybody? I have lots of candy. All right, awesome. You got it. Okay, since you're closer, I'll let you choose. No, no. Greedy. yeah, all of it. Yeah, very good, very good. Okay, so I knew I'd forgotten something. Okay, so let's go back to what was next here. Fragments, yes. Okay, so one of the things is if you start doing a lot of this, you are going to build these gigantic, massive multi-page queries, which are going to get really annoying to look at. So fragments are basically kind of like little subroutines, if you want to think of it, on your query. So we can create a fragment down here that says we're going to do a pilot fragment, this piece on a person. Person is our data type. We want the name, the home world, and the name. So this is basically the same as the previous query we just had, but we're kind of collapsing it down. We had all of this before up here, and now basically we're using the fragment, the ellipses, the 3 dots. Anyone use ES6 and spread functions? Yeah, it's okay. Yeah, a few people could. Okay, so basically they ripped it off from that. So that says, take this thing here. So if you use a ES6 spread function, it allows you to take ... an object, and it basically pulls the object apart and spreads it out within that other object. So basically what that's doing is it's taking this fragment, it's taking this, and it's just sticking it right in there. So same as the previous query, just allows us to do shorthand now. So if you start developing some pretty complicated queries, you can start breaking things down. And because you can do that, you can obviously do multiple fragments. So take that bigger fragment that was below, create it as a fragment, put it up there, but then we can call this one inside here, and so on and so forth recursively. Just allows you to save. You might want to save some fragments off. So, okay. Introspection. So this is what we're seeing right here in the graphical interface. Basically, I can go and actually refresh this. I can basically go say, I've got a type. The type name is person. I want to get some information back on it. What's its name? Which we already know because we put it in there. What are the fields that are on that type? So basically what you see there is a name, a description, the name of this person, and the type is a string. So the name's a string. Birth year of the person, blah, blah, blah. It's a string. So basically I can run through and actually fetch all the metadata about that type that's in the system. That is what this little UI is actually using right now to allow us to show things. It's what it's doing, the IntelliSense, the type ahead, all that, using this information that comes back. So I think we'll see a lot more interesting third-party open source projects that do interesting things with this metadata. Okay, so that takes me back to presentation here. So let me go back over here. Okay. Anyone scared yet on all this? Making sense? What'd you say? So we talked a little bit about syntax, a little bit about type system. We talked some more. I'm going to talk about resolving in a second, and edges, nodes, and pagination. Okay, so the type system, basically, just like any programming language, it has a type system. It has scalars, basic types, floats and integers, strings, stuff like that. Schema, anyone, sure everyone here has probably at some point in time touched a database. So schema is basically the representation of the data in your database, how it's organized. They use the same term here to basically represent what the capabilities of the GraphQL server are for your client. Definitions, how do we define types? Predicates, meta information on types. I want to ask if a type is a class or an object or a scalar, things like that. Unmodifiers, these allow you to strip off interfaces and things and types. Don't worry about it. You don't need to know about it for a long time. Okay, so here's the scalars that basically you get out of the box. You get integers, floats, strings, booleans, and GraphQL ID. That ID is the one that we saw earlier that was like CXQ795, whatever, which is base 64 encoded string of your data type, your database ID and a few other things that makes it unique. The scalars, these are the base scalars that are in there. I'll show an example in a bit. You can define your own scalars. I have a date scalar, a URL scalar, email scalar, a bunch of others that are used. These are base types, but when you define them, you're allowed to put on extra validation. So I can check that the URL is valid. I can check that the URL is any kind of thing I want. Email, I validate the emails, make sure that they actually match correct email standards, things like that. Length of this, length of passwords, you know, password must contain a number and a blah, blah, blah. All of that can be represented in a base scalar definition. These are the ones you get out of the box. I think we'll probably be seeing a bunch on GitHub that people open source. Okay, schemas. So it all starts with the root query. Everyone's seen a root query now. That's at the top. That's your basic top of any query that you're going to do. And in fact, this is a little bit incorrect. It all starts with a root something. There are actually two things at the root that you can do. One is a query. Another one is a mutation. Mutations are, you know, databases are pretty boring if all you can do is ask them what's in them. You're not going to have a product that lasts very long if your users can't actually put any data in it. So mutations are the way that you actually get information back up and modify in your database or your backend. Mentioned a little bit before, you can define your own types. You can define and override the serialization on a type, because I have a date type that takes dates, but I don't want to put dates over the line, so they actually get serialized to a string and then come back and forth. You can add enhanced validation to types that I mentioned. And then from any schema, and the schema is just written in regular JS, we'll show, is that you can generate schema and sun. There's no sun. You can generate two things from any schema. One is, yeah, it was supposed to be Jason. Sun works better. You generate schema and sun, Sanford and Son. You can generate a human readable schema, which will show that looks a lot like, anyone here used Facebook Flow? It's a typing system. 1, 2, 3, awesome, yay, cool. Early adopters, yes. It looks, the schema output, the human readable version basically looks a lot like a Flow description. I suspect that over time, you'll see the schemas here in a minute. They're a little bit verbose. I suspect over time, as Flow gets more along, that we'll actually see things done using Flow definitions, but still a ways off. It also creates a JSON-based schema for the clients to use. So somehow your client kind of has to know what's going on over in your server, your backend. You can do that one of two ways. You can do the introspection that we talked about earlier. You can go and query, ask what all the data is. But when we get to Relay, you'll find out it's much nicer if you already have that schema. When you are building your backend with Relay, you've got queries in Relay. The Babel, who uses Babel? Yeah, okay, more people, yay. Babel has a plugin that basically uses that schema and can type check and error correct all of the queries that you have in your client side. Which is really great, so you don't actually have to go build everything, deploy it, and then have GraphQL barf because your query was malformed. Let's see here. Okay. GraphQL definitions. Scalar type, which we just talked about. Object type, something as an object. An interface. Interface type, just if you've, you know, done any C# or something else, Java, whatever, you've got some concept of how interfaces work. A union is a discriminated union. It's a more, it's a type that holds multiple types and information about what type it's holding, if you aren't familiar with that. An enum, hopefully you all know what that is. Input object type, I don't actually know what this is yet. That's on my list to learn. Hence no definition. GraphQL list, this is the one I talked about returning if you've got SQL and you just want to return stuff and you don't want to deal with all the node and edges. And a very important one, GraphQL non-null. This is an object which is not nullable. So in a number of the queries you want to return something, one of the things that I do, for instance, in the system I have, is that I can potentially fetch a user, and I can potentially fetch their information. So who are they? What's their email? What's their password? Or what's their some auth token, things like that need to come back. You don't want to give that to everyone, right? Obviously, because the system is corrupt. In that case, I can provide a null. I don't use the non-null, and I can provide a null for anything that I don't want to actually return any data back over in there. So if we'd done Darth Vader and you know, we didn't really want to know what homeworld he was from because it was secret and they were going to bomb it, then we just return a null for the homeworld, and we wouldn't actually see a homeworld actually appear. If you're fond of React and things, and you know nulls can be used to do nice things in your React components for what you're displaying. But a lot of things you do want to make sure that you get back a value, so you have that. Okay, so data resolution. So this is a piece of code I have. This is a field on an object, and just a piece of it right here. This is a GraphQL user type, which is defined elsewhere. It has arguments. The arguments are email. I want to get the user by, I want to do the user by email. So I want to query for user, I want to get the email. So you've got to pass in an email, and it's got to be non-nullable, because I won't know what the heck to do if you don't pass in an email. This right here, let me get that for a minute. Each of the, so two things. This is all ES6, so if you don't use ES6, some of this might seem weird. So basically, you can, in ES6, you can do a shorthand object notation. So this resolve here is actually a function, which in ES5 you would have had to have written as resolve : function this stuff. But in ES6, you can shorthand, you only have to put a resolve there, and it knows that the key is resolve and that it's a function as well. So hopefully someone's done a Babel ES6 meetup at some point. This right here is basically async and await. So this is a synchronous function. This is actually a promise. Who knows what promises are? Cool, good. Okay, yay. That's good. So who knows what, who has used ES6 async await? Okay, just a few. Okay. So this is basically a way for me to say this is a function that returns a promise. And in here, whenever I do an await, this is basically saying I'm going to wait on this thing, which actually returns a promise as well. When this promise resolves, this will, I mean, it doesn't wait. It waits the event loop. Basically, the event loop goes and pauses and comes back when we actually have something resolved. But basically, you can think of it as a wait, as waiting on. I mean, that's the beauty of async await, is it allows you to write code that looks sequential, but is actually very asynchronous. So this is basically, this is a function that is actually in my back end, talking to Rethink, that says, go get this user by email, come back. If no user, toss this error back to GraphQL, otherwise return the user. So I'm resolving data here, and this is what, in one of those queries, GraphQL is going to basically call, and this guy right here needs to be that user type, that data. It has to be the shape of that data that's returned. So, but I went with async await because I hate promises. So
are you explicitly making your user type the same structure as the Rethink DB is returned by for you?
Not exactly. There are some things that I might need to do on the server side that I really don't need to expose everything that's over there. So again, and that's one thing to get not get tripped up on. And it's really hard. Is that this is just a representation from your client side of what the back end is, and doesn't necessarily have any. You can map things however you want. So on the client side, again, they think you've got this super graph database that has all these cool things. You can implement them all kinds of ways. This right here, this resolve, if I wanted to, I could have just said resolve function, and I could just return a piece of JavaScript. in which case, basically, GraphQL is looking at this function, it's looking at the function type, and it's using a standard, is this a promise kind of thing, so it looks to see if there's a then, catch whatever in there, and whether it's a promise, and it calls it either synchronously, or if it thinks it's a promise, it calls it, it tries to do promise resolution.
So I was just wondering that, like, there's somewhere in there, like maybe in the fetch user by email function, there's some kind of a transform function that takes the DB data and converts it to GraphQL.
Yes, and if I want, most of that is really just stripping off some fields that I don't want returned. So there's not a lot of conversion, but if you had something that was more sophisticated, yes, you could do that sort of thing.
That's all manual, right? Like GraphQL as a framework doesn't support auto transform.
Yeah. A couple other things. These are the arguments that are passed over. So hence args email, because I want email. The source right here is basically allows you to access some of the AST at the point that you're in. I'll show you another example that shows that. This piece over here is basically a context. Who uses React and knows what contexts are? Okay, a few people. Okay, so basically in React, at the top of React, when it's rendering your component tree, you can basically pass in what's called a context. It's just a piece of data that basically goes down with your tree. And the beauty of it is that you're allowed to pass this in at the top. So I think I've got one more slide where I pass in this at the root of the GraphQL server. And basically I pass in some authorization stuff for JWT tokens. And then over here I pass in a thing called backend. The reason I do that is backend is actually a JavaScript object that I've created that basically has all of these different backend functions on it. But the thing is, by passing this backend in, I can mock the database of the backend if I want to supply a different backend and do some testing, unit testing, things like that. So that's the main reason for doing that. You could have just called, rethink the query, blah, 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 there if you wanted to. But let's see here. Okay, so back to edges and nodes. As I mentioned before, not built in. Facebook provides a whole bunch of functions that allow you to create interfaces and connections and nodes and all this stuff. If you want to have data that is all connected, I highly recommend that you use this extra little library that they have. And it's basically for pagination. If you don't have anything that's pagination, don't worry about it. Just mess with lists. Okay, running on Express. Who's used Express here? Okay, a lot of people. Okay, awesome. So what they have is a thing called GraphQL.js. It's an Express implementation. It actually sounds scary, but if you look at the code, it's really not all that exotic. So that's the one thing. I don't know if this is all sounding complicated or not, but when I describe all this, it seems on the surface a lot more complicated. When you get into it, it's really not so bad. So if you're thinking of looking at GraphQL and Relay, I encourage you to push on. I have written a lot of my React code before any asynchronous stuff I'd done. I was using a React fetch calls and Redux, which is a centralized store for data. And I thought they came out with GraphQL and Relay, and I thought first GraphQL came out, and I thought, what the heck is this thing? And then Relay came out, and I thought, I don't even understand how Relay relates to GraphQL, and I didn't look at it for a long time. Finally looked at it and thought, I had the same reaction when React came out where I said, what the heck are these guys doing? And I went, wow, these guys are genius. Same thing here. So I highly recommend that you actually take a second look if you haven't looked at it. So basically you end up getting a library that basically handles this. So this right here, app use, this is an endpoint in my Express. So basically, go to homepage/GraphQL. This is, don't worry about that. That's authentication if you want to use an authenticated route. And then basically it's going to call this function GraphQL. I get my request in on my Express server, and I'm going to handle it here. These are Lambda functions, ES6, go read ES6 if you're not sure what they are. So basically it comes in here. I get a request. And I'm actually stripping off headers. I'm looking for authorization tokens, pulling some things out. And then this is the real crux of the guy right here. This says return this information, which is used by this piece here. I give it a schema, the schema that I've generated, graphical queue, true. This is the interactive interface we looked at earlier. Set this to false in production, don't set it to true. You'll expose something you don't want. Pretty is whether your responses that come over, whether they're all mushed together or whether they're nice, pretty JSON. So this thing is all turned off in, well, not authentication is done differently, but it's turned off in production. Root value, this is the thing I told you earlier. So basically this thing, this root value gets passed down to our entire query tree. So if you have dependency injections, pseudo global stuff that you need, this is where you send it in. This is a way to handle any error messages that GraphQL hands back. This is just really simple, but you can do a lot more complicated if you want. Okay. Example schema. Am I doing good on time still?
Yeah, one content.
I have boatloads more context. I knew I probably wouldn't get to realize, so we'll make that a separate one. I probably, what? Okay, we'll finish off the GraphQL, which is not too much more, and then we'll do relay as a separate thing if that works for everyone. Okay, so this is example schema. This is a really simple schema here. And this does none of that async resolution anything. So basically, a little concept here called hello. We're going to create a greetings type. And the name of the type is greetings. That would show up over in our metadata. The fields on greeting are hello, which is of type string. Okay, so this is a new type that we're actually going to use in our system, type system. So here's our schema over here. And at the top level of your schema, you have to pass back two things: your query types, or your query type, and, which I don't have here, your mutations, if you have any mutations. Mutations are complicated. That could be a whole other talk in itself. So basically, we're going to call the name query. That would be that's basically the name of the query data. These are the fields. These are right here, greetings. This would be the equivalent of person, all starships, whatever. Those were all at the root. You can put them all here. So this field here, greetings, is a greetings type. And then we need to resolve it. So this is maybe a little bit closer, but see, this is a Lambda function. This is a function that just says return greetings. So there's no async going on here. I'm just returning the data. Yes?
Wouldn't that be passed in the fields function? Was it a function?
That is passed in the, I think the, remember what passed in there? I think part of the AST where you are in the tree is passed in so that you can do some more exotic things. I actually don't use anything that's passed in so far. Make sense? Questions? Good. Let's see here. Custom scalar. So this is what I was talking about before. This is a URL type. So, since you've got a type system and classes and values and things, you want to go define these things that you reuse, just as, DRY, any good programmer, right, doesn't repeat themselves. So this is a URL type. This is serialize it, parse value. So this is the input and the output. It's basically the same, make it a string both directions. And then parse literal. This is where I actually get in a function that I get the AST, my point in the abstract syntax tree, that big tree that we have there of the GraphQL. This is a regular expression that goes way off the other end of that slide there. So we test it to make sure. Let's see here. Here's our AST value. So in our abstract syntax tree, not our GraphQL thing, this is the syntax, the query itself. We can query for the value, and then we can look and we say, no, that's not a good URL. We can check the type that we have, that's actually handed back to make sure, although actually GraphQL itself does a lot of type validation, so I'm not sure you actually need this. But basically, it says is a kind of string. If it's not a string, they passed us a number, that's not a URL. Although most things would actually get caught up here before you even got down here. The value of the length, I don't think anyone owns a URL of length 1 or 0. And then we don't want our length to be more than 2083. But hey, if you have a big giant REST query, it could be bigger than that. But we are doing REST here, so we're going to keep it at that. And then return the value here. So I'm returning the AST value back. If I wanted to transform it, something was wrong with the value, or I wanted to give a default value, or things like that, I could do that here. So I'm going to pass it back as a default. So in the system I'm building, I've got URL types, I've got email types, I've got user types, I've got bunches and bunches of base types that you use all over the place. Build it. Okay, so build it and run. You pretty much have to use, you actually don't have to use Babel for the GraphQL part. I use Babel in ES6. I recommend everyone else to as well. You also need to run, there's a script that comes, an example script, that basically is a little script, npm script, node script that you run called update schema. And as I mentioned before, this takes your, it actually runs your schema. And then from that, it creates the human readable version and the JSON version that you'll need for a client. If you're only using GraphQL and you're not using Relay or anything, you don't need to worry about the JSON version. If you're using Relay, as I mentioned, you also need the Babel Relay plugin that consumes this schema that it generated. And basically, the Babel Relay plugin, you have to tell it where the schema is, but what it can do is validate all your queries on the client side before you ever send them to the hosts. Make sense? Hopefully more sense than he does. Okay, we're getting close here. One more slide. We're done. So GraphQL misunderstandings. We mentioned this a few times already. All the queries you see are defined by your schema. Don't get tripped up. People do all the time on a common one. I'll give you an example of Facebook and a lot of their examples. The root query is viewer. And you're like, what the heck? Where's the viewer keyword? I like all of it. And viewer is basically their thing that says, I'm going to resolve to whoever is currently viewing this. So if I've got a logged in user, then viewer is whoever is logged in, and they can access those parts of the tree. If they aren't logged in, then they're an unknown user. So viewer, node, edge, all of those things are made up things. You can change them to whatever you want, if you like. GraphQL is JavaScript only. Nope, that's true. They've actually already got ports for Python, Scala, Go, Ruby, and who knows what else. There's a whole bunch of things out there. That's good and bad. If you're trying to look for things on the web, make sure to do GraphQL and JS if you really want JavaScript, because otherwise you start picking up some other things. As I mentioned, GraphQL requires special communication protocol. Nope, I'm using WebSockets. Like I said, the basic part is really just using a single REST post call. When we did those calls earlier, actually I was going to show you that too, which I didn't on that time. I was going to show you the network traffic, but basically, and in mine I actually mix and match because I actually have WebSockets running in production and development, but I leave the REST call on for the graphical, the introspection UI that we have. So what else? Let's see here. Quick other things. Okay, so I think that the next starts to get into Relay. Let me see if I'm going to fast forward to the end of the thing really quick. Okay, there we go. That's not too bad. Okay, so let's see. How about that? Thanks. Questions? Other questions? I make a couple more. Excuse me? I will post them. They aren't right now, but I will get them posted. A couple other things. If you're using all of this, and you do get to the Relay part, and I do a Relay part, you can use this on React, and you can reuse this on React Native, so both of them support it. And if you follow Facebook, F8 was their conference last week, and they further extended the React Native support for Windows, HoloLens, Xbox, a whole bunch of Samsung devices. So you can pretty much write JavaScript and React and deploy to everything on the planet, I think. So, which is why I like it so much. So, and here's this. I didn't put my email on. I probably should have. But you can find me on the meetup if you need to get hold of me. Got any more questions?
Any other questions?
Other questions?